Dynamic access policies that we can implement on the ASA. Let's begin. I want you to imagine that you and I are sitting at the office, we're having a chat, and all of a sudden both of our cell phones start vibrating, and we both get text messages that there's some new worm making its way across the internet at blazing speed. And we also identify the operating system. Let's say it's Windows 7, just as an example. Could be Macintosh, could be Linux, but for this example, we'll say Windows 7. And what we want to do is we know that we have, let's say, hundreds of customers who come in via VPN. But until we can lock this down, we don't want any new VPN connections coming in if the operating system at the host is Windows 7. So how do we do that exactly? I mean, because we could have a user that could be bouncing around between machines. How do we control who can come in? Well, one of the benefits of using something called a dynamic access policy is that we can have our VPN users' machines, we can interrogate them. We can find out if they have things like firewalls present, or do they have antivirus present, or are they Windows 7? And based on that interrogation, we can create and apply a dynamic access policy just for those types of connections. So we could stop all the Windows 7 users from having further access into our network until we solve the problem. So that's what a dynamic access policy can do. It can, based on a set of criteria, dynamically give or take away certain rights of permissions. And the reason we would use it is in just this case, where we want to classify maybe a certain type of machine with a certain posture to allow or not allow that type of physical machine on our network. It's important, I think, to see a baseline of what normal looks like before we start filtering. So before we start filtering out Windows 7 machines, for the example, let's take a look at what normal looks like for this user coming in from a Windows 7 machine. Here's the machine out at 192.168.1 something on the outside interface of the ASA. I'm going to log on as that user. They've got some nice options due to the plugins. They've got some nice bookmarks. They're all fine and dandy. We also have a browse option, so we could type in the actual URL we want to, click on browse, and reach those resources which are currently on the inside or the more secure interfaces of the ASA firewall. To create a new dynamic access profile on the ASA, we'd go to this location right here, and I've got a policy waiting for us that we can just edit. It's called No Access for Windows 7, and here's the details of that policy. It's a giant if-then statement. It says if the top half matches, then we're going to implement the bottom half. That's really all it is. So in the top half, what options do we have? Well, we can say we're looking for certain specific things, or we're looking for the absence of specific attributes. In this case, I've said anybody coming in on a specific connection profile. I've also specified that another condition for a match is that the operating system has to be version 7. And we could have gotten very specific with this. We could have said XP with this service pack, or Windows version 7 with this service pack, and so forth, and got very detailed. In this example, just as a broad example, I'm going to use anybody who's coming in on this tunnel group and anybody who has Windows 7. Now, what's going to happen? Well, the bottom half is about the what's going to happen. And right now, there's no restrictions in place. But we could say, I want to go ahead and I want to set up additional web type ACLs. In fact, I've got an access web type ACL that says deny everything. I'm going to add that. I also want to set up a function that says disable browsing of any type. So with those two in place, now what this is going to do is going to say, okay, now anybody who's coming in from a Windows 7 machine, they will not only be able to not get anywhere because of the web type ACL that's applied to them, but they also won't be able to browse for anything. So we're killing them twice. Now, from a customer's perspective, what does this look like from the browser? Let's head back to the client's browser and we'll take a look. Back at the browser, I'm going to log out, and then we'll log back on as that exact same user. And that user was engineering user, and the password was something very simple. And if we take a look now, look what's missing. Previously, we had this beautiful browse bar that is now completely removed, and due to the web type ACLs, because they are filtering all traffic, none of these bookmarks are going to work either. We've effectively stopped everything from this machine from going through the ASA and into our network. Now, once we find out what the worm's all about, we can take our preventative measures, we could remove this dynamic access policy so that the user could log back in and have normal access restored. In this MicroNugget, we've taken a look at implementing a dynamic access policy. And what makes it so dynamic? The answer is it can dynamically be implemented based on a set of conditions. Now, in a production environment, we might have something like policy that says you have to have an antivirus installed, or you have to have a personal firewall in software installed. So we could be looking for those. And if those functions didn't exist on that host, we could deny access based on that. So there's lots of applications for the use of dynamic access policies. We demonstrated with a simple dynamic access policy that was looking for Windows 7, and as a result, it restricted browsing on the internal network from that client. It also set up a web type ACL that was filtering all further web type traffic from that user. I hope this has been informative for you, and I'd like to thank you for viewing.